Hello everyone, I am Priyanshi Khanna, a data science and business analytics intern at the Sparks Foundation. So my first task was making predictions using supervised machine learning. Here I've been provided a raw data and I've used Python to make a model over this raw data. So the raw data is this. As you can see, these are the students, and hours column represents the number of hours they have studied, and the scores column represents the percentage scores that they have obtained. So we have to make a model over this data and make certain predictions. For this, first we will import certain libraries, the pandas libraries that we use for easy data analysis through import pandas as PD, and then we'll import numpy through import numpy as NP, as numpy is used for various scientific computations. And then we'll import the plotting interface matplotlib.pyplot as PLT. Now the percentage matplotlib inline, this line is used to plot and render our plots in the same browser. Then after importing the libraries, we will import the data. Since we've given a URL, so we'll assign this URL to a variable data, and to read this value we'll use pandas library as pd.read_csv data, since it is comma separated. We'll assign this value to a new variable im_data. Now since we are sure that our data has been successfully imported, we'll print data has been imported. And to verify whether we have imported the correct data, we'll print the first 5 rows using the head command, im_data.head, and we'll use the brackets. It will give the first 5 rows of the data, and we'll make sure that it is same as the data that we have to work upon. Now after importing everything, we will start plotting to find if there is any relationship between the two variables, the hours and the scores. For that, we'll use a plot function as in this way, im_data.plot. We'll assign the x-axis to the hours and we'll assign the scores to the y-axis, and we'll plot in an O fashion, dot fashion. So we'll use style is equal to O. Now to better comprehend the graph, we'll add on the title and the labels of the x and y axis using the commands plt.title hours versus scores graph. It comes here, the title. Then plt.x_label hours studied, it labels our x axis. plt.y_label percentage, it labels our y axis. And to render our plot, we will use plt.show. So now in the plot we can see that there is some linear positive relationship among the two variables. Now we'll divide our data for further analysis. We'll divide it into the attributes and labels, or you can say predictors and the target values. So we'll use an x variable and a y variable. We'll assign the hours column to the x variable and we'll assign the scores column to the y variable. So we have divided our data into two. For dividing, we'll use the ilog function since it helps in extracting the rows and columns, and we'll assign the first column, that is the hours column, to the x variable. We'll use dot values to make it into arrays. In a similar way, we'll assign the scores column to the y variable. After dividing our data into the predictors and the targets, we'll split our data into the training set and the testing set. So I have decided to split the data into 80-20% ratio. For training, I'll use 80% of the data, and for testing, I'll use 20% of the data. For this, I have to use train test split, train_test_split function of the model_selection of the scikit-learn library. So we'll use the command from sklearn.model_selection import train_test_split, and we'll split the data using this command train_test_split x, y, test size is equal to 0.2. 0.2 represents 20%. As you can see, the test size is 20%, so automatically the train size would be 80%. And we'll use the random state is equal to 0 or null. This represents that how many times, it doesn't matter, we'll run this command, the output would be same. So it won't be a random, it won't be random. So we'll assign null to random state. This helps to split our data into training and testing sets, and we'll assign it to the trainings x training set, an X testing set, Y training set, and Y testing set. Now, after splitting the data, we'll start training the 80% of our data. For training, we'll use the linear regression function of the linear model module of the scikit-learn library. So for this, we've used this command from sklearn.linearModel import linear regression. Now we'll make an object of the linear regression using a constructor. For this, we have used lm variable is equal to linear regression brackets, and we have fit our data accordingly using the fit command lm.fit x underscore train y underscore train. Now, since we are sure that we have successfully trained our model, so we'll print model has been trained. After training a model, we know that when there are two variables and there is a linear relationship between the two variables, mathematically we use the line y is equal to mx plus c, where m is the slope and c is the y-intercept. So in a similar way, we'll write line is equal to lm dot coef underscore coefficient. This gives the slope of the graph m. We'll multiply it with x to get mx plus c. C is here lm dot intercept underscore. So this gives us y-intercept, and this corresponds to y. So line is equal to lm dot coef underscore x plus lm dot intercept underscore. This is our regression line. Now we have to plot our test data and the regression line. So we'll use a scatter plot to plot our test data. For this, we'll use the command plt.scatter x comma y, and we'll plot the x and the line using plt.plot x comma line, and to render the plot, we'll use the plot.show. So this is our plot of the test data and the regression line along with it. Now we have trained our model. Now is the time to predict through our trained model. So we'll predict through our trained algorithm. For this, first we'll use the test set and we'll print the test set, the x underscore test. This is an array. It has been printed here, and then we'll use the predicted the x underscore test to predict the y values, the corresponding y values, that is the corresponding scores values. This is the r's and capital Y represents the scores. Now to predict the scores, we have used the predict function. We'll take our object as defined earlier, lm dot predict according to x underscore test. This predicts the corresponding y values or the scores values. Now the this is predicting the scores of testing data of ours on the basis of our trained model. Now since we have certain predicted values and certain actual values, so we have to compare both the values and decide whether a model is fairly correct or not. For comparing the actual values and the predicted values, we'll use a data frame for this of the pandas library. df is equal to pd.dataframe, actual is y underscore test, and predicted is equal to the capital Y that we have predicted here. Now this represents the actual and predicted data. Further, there was a question that what will be the predicted score if a student studies for 9.25 hours a day. So ours is 9.25. We'll predict using the hours, we'll predict the score. So we'll print number of hours brackets dot format hours. Format is used to put the hours value into this curly braces, and we'll print predicted score dot format pred 0. This is the predicted score, and this gets into this. So this is our output, number of hours and predicted score, and then we'll calculate the mean absolute error using the metrics function of the scikit-learn library. From sklearn import metrics, and then we'll print the mean absolute error using metrics.mean underscore absolute underscore error y test comma y. So this is the mean absolute error.